Good afternoon. Welcome back for day 2 of the CCSQ DNA Fall Data Camp. Let's review today's agenda before we get started. So first, we're kicking things off with Introduction to R Coding in Databricks, presented by Kyle Webb. That'll be from now until 2 o'clock. Then we have 2 presentations from Derek Cruikshank, Introduction to Python Coding in Databricks at 2 p.m., and then Python Coding for SAS Programmers at 3 p.m. And then we'll be rounding our day out with Introduction to Machine Learning using Python and Databricks by Deshane Joseph, and that'll be from 4 to 4:45 today. A few administrative announcements before we get started. So just as a reminder, please remember to stay muted with your camera turned off to minimize distractions. Also, please use the Zoom chat to ask us any questions or submit your thoughts. At the end of the session, the questions will be answered by our session speaker. Okay, let's begin our day with our first session, and that's CCSQ DNA Data Camp, our Demo 101, and this is presented by Kyle Webb. Kyle, I'm going to turn it over to you to give us more information about yourself and our session.
Sure. Thank you, Julia. And hi, everyone. My name is Kyle, as Julia mentioned. I'm a data engineer with the QDAS data management team, and I have, just for the purposes of this demo today, about 10 plus years of experience with R and handling data in R in my work experience. So what we'll be going through today is really just sort of bare bones what you can do with R in the Databricks sort of an environment with a notebook. And I'll just give some quick tutorial on things that we can do. And then afterwards, after this presentation, I'll share the code with those on the call and I guess the CCSQ group at large to be able to read the notebook and use the code yourself. So could you go to the next slide, please? So at a high level, the topics we'll be covering today with that notebook are listed as follows. I've broken out the notebook to really cover each one of these, and hopefully we'll have enough time to get through it all. Feel free to put any questions you have in the chat, and we'll try to address your questions as time allows. So without further ado, let me share my screen if that's all right. Okay. Okay. So could someone confirm you're seeing my screen?
Yes.
Great. So basically what I've done for the purposes of this demonstration is to create a notebook, but not just within my own workspace, but actually as a repo in GitHub. And you can see that when you go to your workspace, you'll have your workspace here of your user and then notebooks that you have there. But then also in repos, you can see certain Git repos that you have access to in GitHub. And I've actually created a demo branch here today for our purposes to run through this notebook in that repo. So just a quick plug there that GitHub is integrable to the Databricks environment, and you can use that. Some other, yes.
Real quick, can you make your screen bigger?
Yeah, I can try. You just mean zoom in?
Yeah.
How's that?
Looks good.
Okay. Yeah, so the other thing just to note is that Markdown can be your friend when you're trying to, sorry, I'm getting a lag here. Can be your friend when you're trying to actually like break up your code base in a notebook. So as you can see in this cell, I'm actually calling Markdown, which is you can think of as just like a hypertext language to basically prettify what your cells are saying. And here when you use this notation of the hashes, you can set a heading level for different cells in your notebook, and you can actually collapse those cells into that heading. So if I do that there, you can see that the cell is hidden, and actually these are all the sections that we'll be going through today. You can also, with Markdown, as this cell shows, embed links So here I just have a link to the Wikipedia page on R, and then add bulleted lists if you want to. This is really helpful for just, when you share with other colleagues or something, instead of just commented code, it's really spelled out and organized in a nice and neat way. And you can even see there's a table of contents that we can view to be able to see everything that's involved, and you can collapse things this way as well. On top of that, there's also, you can see the folder structure of where you're at locally with this notebook. And again, we're working in that repo here. And in this area is where the notebook is located. Some other just, I guess, housekeeping things. We're working in the R only cluster. So this is the cluster that's available when you want to actually run R code itself. So make sure you're running in that cluster itself for your org. And then make sure that R is the source language for the entire notebook. You can actually set it to others, in which case when you run a cell by default, it won't actually invoke R, but a different programming language. Okay, so let's get started. And the first thing I wanted to start with R is package management. So packages really just are rolled up source code that makes using R and functionality of it a little bit easier when you're trying to call other functions or things that people create that are open source. So you can actually see the installed packages that are available on your cluster by running the installed packages function from base R. And we can see there's a long list here, right? And actually it cuts off quite a few of the other packages that are by default available. And if you wanted to look for a certain package to see if it was available, you can take that package name and then run system file on the package to see if it's there. Let's see if Pacman is there and something we can use out of the box, and no. So sometimes you might run into this where you have a package you want to use in Databricks, and unfortunately it's not there by default on the cluster. You can then just simply install the package, and then in memory that package will be available. And you can actually do that for multiple packages in a list, as I've shown here as well. But it's not enough just to install the package. When you're working with the notebook, you have to then load it into memory, and then you'll be able to use it directly. So to load a package, we call the library command. You can think of this, if you're a Python user, as like an import of a module. And then Pacman, which if you remember was the package I checked that was available, can actually load packages in a sequential format, which doesn't actually happen through library. You would have to do like library of SparkR, library of data table, but this makes loading packages a bit more clean. So that's pretty much it for package management. I think in the future, there might be capabilities to, for your organization, have this laundry list of installed packages that you want specifically on your cluster. At this point, this is just sort of how this is handled. So if you want to install a package, you can directly do that. So we'll move on to base R. And when I say base R, what I mean is that, from the original binaries of the programming language, what can be done, what's available from the foundational programming of R, what do you use? So this isn't relying, if you're familiar with R, on like the tidyverse or dplyr or anything like that. We're really just talking about like bare bones programming. So for R, there's many different class types, and I've sort of listed out what those can be sort of tested with here. If you wanted to, we can sort of check a class type of a variable. Sorry, a little bit of a lag. But as you can see, if I return to class type of setting x equal to NA, then that class of that variable itself would come back as NA. So let's just test that now. So it defaults to X as a logical, but I think you get the point. Any of these are different class types in R, and these are the different ones that we would run into. What's really important, I think, for our purposes, though, are the different types of data structures that we can use in R. And I've listed the 4 main ones out here, as well as their pros and cons, essentially. So the first is a data frame, which comes with a base R distribution. It's traditional table-like structure. Columns, of course, can be in different types, but all elements within that column have to be the same type. And you can attach row names if you want to. The drawbacks are listed here. Performance, there's some quirks with subsetting, like dropping a vector, and strings are converted to factors by default, which is something that you might need to take into account when you load in a data frame. Just as an example, I'm going to use these functions, runif and rnorm. Runif is basically just a way to get random numbers on a uniform distribution from 0 to 1. And rnorm is the same thing, but for the normal distribution. And so if I wanted to make a data frame called X and have columns 1, 2, 3, and have the first column be letters 1 through 5, so A, B, C, D, E, and then 5 random uniform generated numbers, 5 random normal generated numbers, then this is what would be returned. And that would have a class of data frame. So moving on, there's also data table, which you can just think of as a data frame, except it's actually optimized for performance in memory. So this might be something you would use before using Spark, where maybe you have like 1 million plus rows and you still want to be able for faster reading, writing, joins, that sort of thing. The same thing can be shown here. And you can see that there's a little bit of a different syntax here between that and a data frame. And then there's Tibble, which is much like a data frame, but it's really just about formatting and a bit more surly in terms of what operations you can perform on it. So as you can see, like the first column actually shows the data type. And so that's probably a benefit when you're working with something you don't really know much about the data itself. And the last is something that is really helpful, especially when we're able to run Spark on Databricks clusters, is using our Spark data frames. So Spark allows for distributed computing, right? So we can actually split the data across multiple nodes. And those nodes can scale out or in with Databricks on demand. And this requires a Spark environment to run. So we can actually create a Spark data frame in R if we wanted to. The one thing with Spark data frames, and maybe you wouldn't want to use them for such a small subset of data like this, is that it's just not as easy to use more complicated joins or cleaning of data as it would be for something in memory with R, because the tidyverse really does expand and allow for lots of different complicated things that you can do with data. And Spark R doesn't natively allow for the tidyverse suite to be applied. And we'll get to cleaning and transforming and looking at data that way a little bit later. So those are the different types of data. And I'll move on to the next section at this point, which comes to functions. So we're still sort of in the world of like base R itself. And we're just going to talk about what functions are and how you might be able to create and use them. So as I showed earlier, the help function as a way to look at what functions are is helpful. So we, just as an example, I'm looking at the paste function, which you can just think of as a way to concatenate string variables together. By default, it separates those things by a space. And I've created a little function here just as part of this demo. It's called com_char. I guess you can guess what it does. It just sort of takes that paste command and combines one character value that comes in with the new character value. It separates it by a space, which is actually kind of redundant because it already does that, but I just wanted to show that you can set that as an argument regardless. So what does this do? Well, if we set P1 as an object of combine char on the cow jumped, and then run that function again on P1 over the moon, then we should get the sentence, the cow jumped over the moon. Likewise, we could have a more complicated thing where we want to say, hey, diddle diddle, the cat and the fiddle, but there's lots and lots of different calls of comcar. And this is kind of, not a great solution, especially if we want our code to be readable and reusable by other people. So what R does allow for, and something that sets it apart from Python just out of the box, is piping. If you're familiar with Bash, this would be similar to the pipe operator, where you can just sort of roll functions through one another in a logical way. Now, I shouldn't say Python doesn't allow for it, but it's just not like intuitive and as easy as just throwing this in there, because you can do like method chaining and whatever. But anyways, so the comcar function, we can say, hey, diddle diddle. It's easy to just throw that result into comcar again as the first argument, and then the second argument is diddle. We throw that again, the cat, throw it, and the fiddle, and we get our result. So you can think about how piping might come into use cases for yourself when maybe is a more like understandable way. You have a vector of numbers 1 through 10. You want the mean of those numbers, and then you just want to add 2 to that result as a lazy evaluation of a function that you can throw into the chain. But maybe you have like other custom functions that you build other ways, and it's just a nice and easy way to sort of chain those things together to get results quickly and easily, rather than having this long sort of open and close format of the functions. So that covers functionality. Now let's get to working with S3 objects. So as most of you probably know, we store our data in S3 for the most part, and that's what SaaS workspaces allow. When you're writing to your workspace, it's actually storing the data in your workspace bucket in S3. And what I'm going to show here is that we can look at the local storage of the Databricks cluster and sort of work with objects that way. But we can also mount to the S3 location and use those things that you would use in your workspace area. So I'm going to run these cells, and I'm working with a bit of a lag here, so just be patient with me. So when I run this command, we're getting the working directory, which is right like where we are in the path layout in Databricks. And as you can see, I'm still in that repo, that GitHub repo that I talked about. In code, Databricks R. We could actually like change that working directory to be somewhere else if we wanted to. Typically, when you first spin up an R server in like a workspace of a notebook you just created, like you're not working in a repo, but you're like working locally in your user area, it's going to throw you in one of these temporary R server connection areas. And what you can see is that 2 sort of come up. Those are probably the latest 2 that were created. And the latest one is here, here, the one with the later modification time. Let me just copy this because I think I have it different down here. As an example, I'm going to create a temporary data frame that's similar to the ones that we looked at earlier. And this cell will actually take a timestamp. It'll format that timestamp to be of the format year, month, day, hour, minute, second. It'll paste, and paste 0 is basically just another function like paste, except it doesn't have the separator of space. It sort of, strings it all together, no spaces. So I'll do that here. That'll be the name of the file. And I'll put it in this location. And then I'll write this temporary data frame that created as that file name. And because I don't specify or to this location, right? And I'll set the row names equal to false. So I don't want to keep the row names, which by default with write CSV will just be 1, 2, 3, 4, 5 up to 10. So if we look in that location, and FS here is a Databricks magic command that's helpful for simple one-liners like ls or copy to basically see where or list objects in a location. And we can see that our object was created, right? That's the one I just made. And I wanted to demo in this location, we can, like Markdown, we can call Python, we can call SQL by calling this at the beginning of the cell, and we can actually mount. So I've written the file here. Now I'm going to mount to the workspace location that I want to in order to transfer my file. So this S3 path is basically designating the area I want to work in, and I will mount directly to that area. So I'll run that now. Oh, I'm already mounted. So I could unmount and then remount, but basically this mount already exists is what it's telling me because I've run it before. But I can show you that if we just run the same fs command and list that area, we can see that this is like what's in that location in S3. And I've got a zip file called diabetes zip and laptop data CSV, which we'll look at later. We looked at the temporary file name earlier. I'll show that again here. And then I will copy this file to that mount location. And as we can see, our test data frame of 10 rows got written to S3. So this is just a simple example to show with R and generally with a Python notebook too, a way to mount to S3 location that you have access to, and then sort of work in that mounting to be able to write and read data there. I'll move on to the next section, which is about importing data. So for this demo that I have today, I actually used a Kaggle dataset called uncleaned laptop price dataset. And the reason I wanted to use this was because it was uncleaned. So yeah, this is the current directory we're working in. And I'm going to list here the data set that I actually downloaded to this repo in a directory called sample data, and it should provide this file name. So this is the data we're going to work with. I'm just going to read the CSV in and call it laptop df. And I'm also just going to copy this file to the mount location, even though I think I showed you before that it's already there. I'll just recopy it. And the last cell we'll sort of look at for this section is creating a Spark data frame. So we have the CSV file in our mount. We're actually just going to create a Spark data frame from that. So I'll do that now. And after that command runs, we'll show the data frame to see sort of what it looks like. I guess you can already see what it will look like, but we'll run it just to show that it does work. So as you can see, there's quite a few, excuse me, columns here. A company of the laptop that was made, the type name, the inches, I guess that's the width of the screen, resolution, all this stuff. And it's bringing in the unnamed column here, which are the row names. Move on to the next section, just the bigger one, just cleaning, transforming, and joining, which I think is probably what R has the main leg up on Python, at least for in-memory data sets at this point. When we look at this data itself, there's probably a lot of things if we wanted to like model price, which eventually we'll do. You would want to sort of recharacterize or create new categories for this type of data, clean it, and maybe check for if there's inconsistencies in the data, nulls, things like that. So head provides us a function to be able to just like see the first 6 rows of our data. But something that's really helpful in R is this package skimmer. And I don't think I mentioned before, but instead of calling library, you can actually directly reference functions in a package. So skimmer has this function called skim, which is a little bit like summary in base R, if you're familiar with that. But it basically allows you to look at some really high level statistics on your data, and it really helps for things like knowing nulls or missing values. So we can see for these character type variables, there are 30 empty observations, and whether these are the same observations or at different rows, it's unclear, but there are missing ones there. This also gives us the number of unique variables for each of the character variables, and yeah, things like that. So, and then of course there's the numeric ones down here, and skimmer actually provides a tiny little I forget what these are called, but just a little histogram to show sort of how the distribution of values falls out. And we can see the number of missing here to be 30 as well. So let's look at cleaning this data, because obviously there's some missing values. There's some things we might want to change. And so I'll walk through just what we could do with this. I'm going to be using the pipe operator a lot. So again, that it just sort of reads left to right. So what we're saying with this is take laptop df and drop all the NAs. If there's an NA in a row, drop it. And so we'll call that new data frame laptop df cleaned. And we can run skimmer again, or skim rather. And we can see that those empty values and the missing are now 0. So those rows were dropped. I also was looking at this unnamed column, and I'm not going to run the cell, but basically it's just showing you that the unnamed thing is just the row name -1, which I guess is how Python might dictate rows, right? Your index starts from 0. And what we might want to do is sort of mutate this column. And when I say mutate, that basically just means create a new column from existing ones. And so we can take this column, add 1 to it to get the row name in R's format, and then we can deselect that column by running a select and then minus of the column name. And this functionality here that I'm using, mutate, select, these sort of functions for data frames themselves are really a part of the tidyverse suite. And I suggest anyone to sort of look into tidyverse if you're not familiar with it. It makes data cleaning, modeling, all things that you're trying to do in R a lot easier. And this is just one example. But the other thing with this cell is this operand right here. So much like the pipe, this is, and this all comes from the Gritter package. But this piping basically is saying laptop df cleaned equals laptop df cleaned, and then all of these things. So I'm just overriding laptop df cleaned to now include this new column. Oh, I guess I already ran it, so it's not doing it again. My bad. We'll run this and we can see that that column was created. Okay, so yeah, there's row number. Something else that you might want to do, especially if you have a lot of character columns like this, is see what are these unique values? Am I doing with actual values here that make sense, or are there mistypings or things I wouldn't expect, things like that. And so using the piping format, we can take our data frame, select the columns if it's a character, and then using this map function, map the printing of that column and its unique values. So when I run this, it's going to go through each of those things and print out all the values associated with a particular column. So let me get past all of the initial printing here, sorry, and get to the column names. So there's company, got all these different laptop makers, and those seem to make sense, right? Yeah, type name, that works. This is strange, inches. And really this makes me think, oh, do we even want inches to be a character? It seems like this is a numeric value by default. We should probably just leave it at that. We've also got a strange question mark value here. We should probably fix that. Screen resolution, yeah, I guess that makes sense. But even in the future, it might be helpful if we're modeling price to break this down, maybe space this out and only get if it's an IPS panel or something else, or there's different ways once you're actually seeing the data right to think about how we can reformat it. Same thing with CPU. Is there a better way to sort of organize and restructure this rather than just leaving it as its original raw character? RAM, again, looks like something that should be numeric and maybe even the memory as well. Again, we come across this question mark value. GPU, operating system, yep. Weight, that's something we should change to numeric. And again, coming across this. So let's look at those question mark values and how we can do that really easily. I mean, this is just 2 lines in R, is basically filter on if any of all of the columns equal a question mark, show me them. So this is going to run that. And lo and behold, it's the same output, but we have here 3 rows that show up where we're getting question marks for these different columns. And so we're going to remove those. And basically by doing that, instead of filtering and just showing those things, we're going to overwrite laptop df cleaned to say filter that the values don't equal that question mark. And if this notation is a little bit scary or new or weird, don't worry about it. Really just showing here what can be done with R, and building up to that process is simple enough. It just takes some practice. So if I run this command, we'll see that there's no rows that contain question mark anymore. Okay, let's move on to transforming the data. So I'm going to create a new data frame called laptop df transform from laptop df cleaned, just to keep things a little separate. And what we can look at here is checking the variable counts and renaming their values. So you may be in a situation with your data, right, where you have low representation of a certain field, right? And for our case, that's Android. Only have 1 sample. Depending on the model you're using, you may want something with a higher frequency for your different bins, right? So one thing you can do is actually mutate a new column for opsys. We'll call it opsys to rewrite over it. And if opsys is in any of the smaller ones, which 8 or below, is sort of how I've broken it out, we're going to call those other. Otherwise, you're just going to return the opsys value itself. So let's run this and the next one and look at the counts of how that changes. Yeah, so as you can see, other is now a field itself that contains 17 different observations. we'll move on to create numeric columns. So I mentioned this earlier, inches, RAM, weight, all of those seem to be strings, but really for our model later on, it might be better if they were numeric values. And the function that allows us to do this directly is just change the character value to a double. For inches, that's easy enough because those were already sort of characters that were represented as decimals, right? But for RAM and weight, we have these units that are tacked on at the end of the observation. So we can really just sort of clear those out by using this function. I think in stringer package is what it is, but it's in tidyverse altogether, to basically take that unit and replace it with nothing, and then pipe that value to the as double to create a numeric. And then I'm gonna pipe the whole thing to skim to see what it looks like. Okay, so we can see weight, RAM, and inches are no longer variable type of character. They are numeric. And yeah, we have the other stats sort of showing here of how their distribution falls out. So I'm going to rewrite over laptop df transform to basically set those changes in place. Last thing here, I'm sort of seeing the time, we're going to change the price because there's no way a laptop costs this much. It's likely that, and from what I read in the comments on this data set, that it was in rupees. So we're going to use the conversion of rupees to dollars and set that here. There's also a section I have here on joining data. I'm going to skip over this because I think most of us understand joining. And if you want to look at the specifics on how to do that with dplyr, I just have a simple example here of left joining based on the row number from an earlier data set. Let's get to visualization. And I won't click through these. I'll basically just show you the plots I created. But first, there was a change in the data frame that I want to use. So I'm only going to look at character data and then basically pivot long so that each of the variables themselves has the value apple or has the value ultrabook for the type name. So basically taken that wide format and made it longer. And you can take that and basically look at the distribution of each of the like label types within a factor that you have, right? So OPSIS is an example. We have our other category of, was it 14, 17? And we can just see Windows 10 blows that out of the water. And you can actually facet these by the variable themselves. So I'm creating little plots by each of these types, right? I get that the text is really busy here. You can actually like comment that out or delete that based on the theme that you want to try and use. There's a lot of documentation online about ggplot. If you're new to that, again, simple enough, just start building from the ground up and you can get really, really nice looking plots for your data. I'll do the same with pivot longer here to basically do that for the numeric values. So again, I can pivot out and look at price dollars, price rupees, inches, and how those sort of fall out all in one plot. And excuse me. Yeah, and then I think this was one. Oh, I added, this is the wrong title here. So user error. But essentially we've got here is just a box plot of the laptop type and then how those different quantiles sort of fall out for each of the types when it comes to price. So just looking on this itself, it looks like there's really a significant difference between sort of maybe a netbook or workstation, but hard to know without doing the actual t-tests. We can keep going down, but again, these are just showing examples of how to break out by certain categories if you want it all in one plot. And then here's a simple example of just doing a histogram on the price of the dollars and what that looks like. We can see that if we want to model on normality, this wouldn't really make sense. This is a very skewed distribution. So we can take the log. We can take the log of those prices, and I've overlaid a normal distribution with the mean and standard deviation of the price of the dollars. You can see it looks a lot more normal, so we'll just go with that. You get like 2 or 3 more minutes here. I'll sort of zoom through this, but again, I'll make this available so people can look at it. At the end, I'm really just splitting a training and testing set, creating a linear model using ordinary least squares for this model type, and then getting a summary of that model output. You can see that some of these values, some of these variables are statistically significant in terms of their difference between the factor levels themselves. And then we can look at prediction. So if I take that linear model and I want to basically predict on my test data set, my holdout test data set that wasn't looked at all for the creation of the linear model, these are just sort of like tests, right, of the linear model itself, but I can look at the test set and get predicted dollars from that, and then sort of look at how the price of the actual dollars compares to the predicted dollars. Of course, you want things to fall along this XY line here. And for the most part, they do, although there are some that are, I guess in this case, really, really overestimated by the model and really, really underestimated by the model for this observation. I'll stop there and try and take questions. I haven't been looking at the chat. I see it's blowing up. So hopefully we have enough time for that. But thank you.
Okay, Kyle. Luckily, Derek was able to answer a lot of our questions. I think there were a couple left that he had not gotten to. So the first being, can you use packages like SQLDF to write SQL queries on the R-only cluster?
I have not used SQLDF. I would imagine, though, that if you wanted to use SQL in a notebook, again, it may benefit you to just use SQL. I think that would be a way to sort of create a table. But yeah, I don't know exactly. I'm not sure if anyone else on the call has sort of used that package with R before, but.
Another question, can a large file be mounted to a memory mapped file, and if so, how?
Yeah, I guess it depends how large. The specs of the primary node for the R cluster for each org, I think is somewhere like 32 gigs or so. So yeah, it depends how much memory you have available within just that one primary node. Yeah, I think it's 32 gigs, 8 cores for the driver node. Yeah, so that's kind of your limit there. But a good way to actually check, and let me run it right now, how much free memory you have.
Did you want to share your screen again? Would that be helpful?
Oh yeah, would. Thanks.
No worries. Hang on 1 second. Okay.
So you can run system commands from R, and basically you can just run free, and then I think the flag puts it in megabytes. But yeah, you can see how much free.
Okay, there was a clarifying question on this one.
Okay.
They meant heap memory. Can we freely use that?
I'm not sure.
Okay. All right. So I'm gonna not share again, just in case you want that for the next question as well. Can you read a SAS data set into R?
I have not tried this. I know there are ways to integrate SAS with R, and I would advise to sort of peruse online on what people typically do in those situations. I would be very, very surprised if someone has not already tried to do this. But this is open source. It's, I'd imagine there's something similar out there to do this. So.
Yeah, and we actually have done it on the Python side. It does require we use the SAS 7bdat Python package. It does require that DBFS mount functionality, as well as we actually had to then copy from the mount to the local file system in order for it to be able to be read. But it is capable of doing it on the Python side. On the R side, I would imagine there's multiple packages that do allow for that as well. And again, one of my answers in the question around the mount is that we are working on documentation regarding best practices and exactly what we would recommend and how to utilize that functionality as we work more with the Databricks team and the security team to ensure that everything is good and what the subtle nuances are between file types and needing to keep it to a local file system versus being able to write directly onto the DBFS mount. So there will be definitely more to come with that.
Thanks, Derek. Does R or the R notebooks have the capability to schedule jobs to run at a future time similar to VIA?
I would say yes, there are ways to schedule jobs. And you can do that for any R notebook. It doesn't have to be R. But yeah, I think, there's even a schedule. I'll share my screen again. Sorry.
No, you're good.
So yeah, up here, the top right, there's a schedule command. You can actually set a schedule of when you want the job to run on what cluster. Although, Derek, correct me if I'm, you can set this to the R cluster.
Yes.
Right?
Yeah,
Okay.
you can. Yeah, it's the R, your organization's R cluster that you can schedule the notebook to execute, based on triggered events and such. That it would then run within the jobs workflows.
Yep.
Okay. I think at this point, all of our questions have either been answered in the chat by Derek or Kyle and Derek verbally. But in the event that we've missed any, all questions, or even some that we weren't sure of, all questions will be researched and then documented and added to the Q&A part of the Data Camp Confluence page. So definitely keep an eye out there. I know that we are running low on time. So at this point, I think that we're going to wrap our fourth session up. Thank you. Gosh, sorry, my deck is okay. Thank you so much for joining us, and thank you to Kyle for presenting today and Derek for helping out with questions. Our next presentation is going to begin at 2 p.m. and that's going to focus on Intro to Python coding in Databricks. And that will be with Derek. So we're going to take a break now, but be sure to join us back in just 5 minutes for that session. Thank you so much.